Good afternoon. It's Dwight Mitchell here from Mitchell and Son Additive Manufacturing. Well, here we are at the end of the first month. We are back into February at the moment, which is crazy because that's 1 month gone. The Chinese Lunar New Year has started, which is really good. So happy New Year to any of my Chinese colleagues out there, which is it's always good to speak to you guys and get quite a lot of requests from China for different work things. So what I want to talk to you today about and why I've come live is because I want to explain the difference, and I'm sure a lot of people do know the difference between 3D models or 3D modeling, creating 3D models, and 3D rendering. Now you can have the one or the other. You can create a 3D model without having to render it. So just close something down there. But there is also a difference, a vast difference. So what is 3D modeling and what is 3D rendering and what is the difference between the two? What is the difference and why? Okay, the way 3D modeling and rendering are different is to demonstrate the results. When you 3D model an object, the results will be the fact that you have the geometric or the geometry of the item, so the inner dimensions of that item. So if you think about it, you have a part and you look at a part, say you give something, say like this. This is a very good example. So you say that to me, okay, there we go. Can you 3D print that for me? I say, yes, I can. From the outside, so from a 3D rendering perspective, you can think of it as a real world object. So you look at it, you say, okay, that's what I want. And it looks like a real world object. But within that real world object, there are dimensions, often, sometimes, not always, but hidden dimensions, which we don't always see. So from a 3D modeling perspective, I need to take that part, take it out. If it's an assembly, I'd have to take the whole assembly apart and measure each dimension and create a technical data. And in the olden days, when before CAD, the way that used to be done is you have a really big whiteboard. You have rulers and pencils, and you have a drafts room, and you have about 4 or 5 different people taking the part apart and then drawing each individual part. Or someone might just take the entire assembly apart and then have to draw each and every single item individually, and then you've got a pile of 2D drawings. With CAD, it is different, and I'd like to just show you how, because with CAD drawing, it's all done on electronically. So you give me an item. I still have to do the same process. Take it apart. If it's an assembly, take it apart and then measure each and every single part. All the dimensions, the interfaces, oh dear, that's gone in my brain. The interferences, so the tolerances is the word I'm looking for. So I have to sit and I have to measure all of it. Just open the window, it's getting a bit hot, which is strange, but then it is getting hot. So it's been able to take that part apart. So I want to just show you a very quick demonstration. I was given an assembly some time ago and asked us to redesign that, remanufacture it. So I would go.
Hi, my name is Amit Sahai, and I'm a professor of computer science at the UCLA Samueli School of Engineering. Today I've been asked to explain zero-knowledge proofs in 5 levels of increasing complexity.
That wasn't supposed to happen. So I do apologize. That wasn't supposed to happen. Not sure what was going on there. So if I create, no, where's my? Okay, just hold on. Why is that not coming up? So if I open the window, there we go. Okay, so if I share this with you, so what this is a 3D model that was given to me of it's a metal bracket which holds the tailgate of a Range Rover closed. So these are for a classic car company up in Oxford. And so this particular part, they were finding they were struggling to get hold of. So it's now, so they asked me, can I redo it? So creating the 3D or the drawings, what traditionally would have been the flat 2D drawings, we are now creating electronically, and this is how the process. So I would take the part, strip it down, measure every single item. As you can see here, it's measuring items, making sure that each item fits in the way that it should, checking the tolerances, the alignment, making sure that even that little pin, the tolerances between that pin, so the pin can slide through easily, it doesn't catch, ensuring that it's on this top bit of the bracket, that fits properly, so that we have a working part. So when the customer comes to refit that or to have that remade, they've got their working part there, and it's ready, and it's up, and it's running. So that's the 3D, creating a 3D model. Excuse me. So from the 3D model, I can then render it. Fusion 360 does have the facilities within it to render. So it's, in other words, creating a real world view of the electronic data. But what you can't see is you can't see all the dimensions. You can't see the drawings. You can't. So it looks like it should in real life. So what we have here is what I've got here. If I just share my screen again with you. Sorry, just go back in here and share my screen with you. These things don't always work. It doesn't always work the one way you want it to work when you go in. So here I have a 3D model. That's the item that I just drew. So it's rendered in the real world life. So you can't see all the dimensions. You can't see all the tolerances. You can't, and that is a rendered item. This item can then now be used for a variety of different things. For display, it can get put into an animation. It can be used for advertising, can be used for all kinds of stuff. So there's a lot of different software that this can go into. I could export this into Blender, and it would capture all the material, it would capture all the surface finishes and the colors and everything. So, and then you could use it in a short little video, or in a in some kind of animation. But you can also use it for creating these type of things, to try and explain the little videos, short little videos where customers can see, okay, this is how that part works, this is how that part goes together, this is what the material does. So it's, again, another way of using taking a 3D model and using that as a rendered item for purposes of sharing information, for purposes of sharing that with your customer, so you can see that you've drawn it in the way that he wants. And it's also multiple purposes. What we've done a couple of times with a rendered image. So we took our logo over here in the top. If you look in the top corner on this side here, on this side here, we took our logo and we created a 3D model of it, and we've put that onto our website. So if you go onto our website, you can actually see our logo in action, if you like. So I'm just going to share my screen again with you, so we can have a. Wrong thing. Sorry. Share. So what we've done is we've been able to take these 3D models, and we've created little adverts with them by in very different ways. So this 3D model, as you can see, I've taken the image, created a 3D model, and then I've rendered that and created a short little animation of our logo moving, which you can see on our website at the moment. So somebody asked me for a sample of, asked me if I can do this. I said, yeah, I can do it. So was inspiration for me to create that for a 3D for that purpose. So there's again another reason for creating 3D models is to be able to do stuff like that, little animations, little thing. And I'll show you another little animation we did, an advert that we did some last year, which again highlights the fact of being able to create a 3D model and then use it for render that and use it in programs like Blender. This little advert was done in Blender, but we used our logo, and there was that car in the background. If I just go back, I'll just push this all the way back to the car, to where I wanted to be there, and pause. So that car we created in 3D in Fusion 360, again from flat data from old drawings, because this car is pre-war. So the only drawings you can find online for this car are all 2D drawings. Then created our 3D logo again, turned that into a 3D model, and then just created a short little animation just to give it a little bit of interest, to make the advert just a little bit more interesting. But 3D models can be used in movies today. There's a lot of movies that use 3D modeling today instead of actually using real people or real animals or real things. So that's the difference between that's 3D rendering. So that's taking a 3D model and rendering it, making it a real life thing. So you can use it in variety of different ways. Now, 3D modeling, the same type of 3D modeling that I create in Fusion 360, which you guys saw earlier, is that that same 3D modeling can then be used for all kinds of other applications. It doesn't have to only be used for 3D printing, because 3D modeling is used traditionally today in traditional manufacturing. Now, as I'll go back to a bit of history here, probably up until about the late 1980s, whenever any drawings were done, you had these all engineering, all manufacturing businesses, they had a drawing room or a drafts room where you'd have probably 15 or 20 draftsmen stood, or depending on the size of the company. And they'll all have these really big boards with massive pieces of paper, and they'll all be drawing with pencils and measuring instruments, drawing what is required. So that's probably around again the late 80s, early 90s. CAD came into the thing, which is CAD stands for computer aided drawing. So these engineers now, who all stood around these big whiteboards with a big massive ruler and a pencil, and that all got taught now how to use computer aided drawing. So instead of getting given the whiteboard, you get given a computer and you get taught how to draw electronically. Now, there are a number of CAD softwares that people use, and it's a massive variety in it. It just depends largely on people's preferences and what people want to use, whether and what they need in that. And there's many. I mean, even this building behind me and the images behind me there, they would have drawn that in some kind of CAD software. So that's CAD in a nutshell, a bit of history in CAD. So with the 3D models that I showed you earlier, where I can create it using CAD, let me just pull this back and say, I'll just bring. So that 3D model doesn't only have to be 3D printed. People think, well, okay, if a 3D printing company like mine creates a 3D model, that model is only good for 3D printing. That is not true. It depends on the design. It depends on how it's drawn and what type of machine you have in mind when you're drawing it. So this particular item, which we have here, which I showed you, which is now in CAD. This is the CAD drawing of that with and this was showing a 3D model with all the drawings in there, the components, the construction of it. This is where the 3D modeling comes from, rather than the rendering, because this will then be rendered. I mean, I'll show you here. It does have an option for me to render it in Fusion 360, which is now not going to work for me. But this particular item, so there we go. So it is now, that's rendered in a real world environment. So you can show that off to customers, take pictures of it, use it for whatever kind of reason that you want to use it. So that's, but I needed the 3D model to be able to render. I mean, that's a bit of a given. But this particular item, which I was talking about, this item doesn't only have to be 3D printed. It is actually suited more to the traditional manufacturing processes. So that can be used, put onto the traditional type machines. All computer machines, all machines today. So your electronic laser printer, your CNC mill, your CNC lathe, your CNC toner, your 3D printers, all use what is called a G code, which is a computer code. So it's taking that image and converting it into a language that the computer can understand. Now, not all G code, not all machines can understand any G code. Each machine or each type of machine has a specific language that it can only read. And I'll show you a couple of examples what I'm meaning. So this is a G code sample for a CNC lathe, which is that's the drawing. These are, and all it's doing is it's showing the coordinates, where it goes, how much it's got to cut, what angle it's got to do. So that's all programmed in. So it can't read a drawing. It's got to be told what to do. So you'll have somebody standing programming this in. And this is the G code for that. So it'll tell it where to go. And all these letters mean something. X and Z obviously is your coordinates, X and Z, backwards and forwards, or backwards and up and down, and forwards and up and down, X, Y, and Z. And then the rest will be for whatever that type of machine is. Then you have a mill, like I said in here, it's just going to machine out that little block with a little step on it. And again, you got your different type of coding that you can have. So I'll also show you let me just see, let's open up with a notepad. And then, so in here, so I'll show you what I'm talking about with G code. So what we got here, so this is a 3D printer's G code. So it'll tell you where to print, how to print, where it's telling you the X, Y, and the Z coordinates, how far to go up, how to come down, when to start, the temperature, and all that kind of stuff. So that's on a 3D printer. Now I forgot to share earlier, which I want to just share here. This is your milling code. So there's your item. It's the same. That's the G code. And it's the same. You've got to think of G code in the same way that you think of languages, human languages. German, French, English, Portuguese. They have the same base information, but they are completely different, and the one can't understand the other. So a computer-aided lathe won't understand a computer-aided mill, and a computer-aided mill won't understand a computer-aided 3D printer. So there's quite a few differences, but depending also on the type of item, the 3D model that I created, which again, I'll go back to that. So this 3D model that I created in Fusion 360, because of the dimensions that could that can be 3D printed, or that could go on a traditional machine, because it's the dimensions and the angles and it's very easily to be able to do. So this here would probably be cast, this bottom bit cast out, and then put onto a mill or a lathe and just turned off, finished off. And then you got your top bit, which is just a piece of metal welded together, drilled out. But that doesn't have to be 3D printed just because a 3D print company created the design. And that's the beauty. That's the wonder of 3D modeling, is it can be used across any modern computer CNC type machine. It's got to be when designing, and this is the key thing, when creating a design, so something with really intricate, fine detail, can't go on certain machines, can't go on the traditional machines, because of the fact that it's very detailed and the machine can't get in there, where a 3D printer can. So it's kind of, you've got to when you're designing, when you're creating, reverse engineering a part, you've got to do it with in mind, what type of machine are you making this part for. So that's that's pretty much the difference between 3D modeling and 3D rendering. It is you can't render obviously without a 3D model, but the 3D render is like this image behind me. It's real world type thing, but 3D modeling, you've got all the technical data in there. Now, so I wanted to just share something which is really exciting. I'm not going to share all the details because I haven't quite got everything set up, and I know I have to go do a course before it all comes into place. However, I'm hoping that by the end of February, beginning of March, because we know we've just come out of a 2-year pandemic, we have come out of a period where it's been a very serious struggle for most households, for most businesses. It's been a financial struggle. I know a lot of people don't like to talk about finances, but it has been a financial struggle for a lot of businesses, big and small. Sadly, with a heavy heart, a lot of smaller businesses haven't made it and have had to go under. There are a lot of bigger businesses that haven't made it and have had to close their doors permanently. That is a sad reality of where we are at this point in the beginning of 2022. So with that in mind, we understand that our fees and the cost of making a part can sometimes hinder people from creating or making things that they that are required. 3D printing isn't as expensive as some of the traditional alternatives to manufacturing, like injection molding or getting parts machined at at 175 pound an hour on a traditional machine shop floor. But it is still, for some, quite an expensive layout. So we have been working with a partner, been in discussions with a finance partner for the last couple of months now, and they have now agreed. We've signed a contract where we will now be able to provide, through a certified financial partner, finance for parts. So you can buy now, pay later. In other words, and it's not like you can pay later, take 6 or 7 years to pay. This is short term. So it's if you buy anything under £500, or if your order is less than £500 through us, we will be able to offer you a finance where you can pay off in you pay the first payment on receipt of order, and then 4 other fortnightly equal payments till that item is, which kind of spreads the load a little bit, makes it a little bit easier. We can tell you that we can offer finance up to a maximum of £3,000 purchase, which will then say the first payment would be, or 20% of the cost of the invoice would be paid upfront or on the receipt of the invoice, and then 11 equal payments after that, spreading the load, making it a little bit easier and a little bit more affordable to be able to purchase items or 3D printing and 3D modeling and our services through you. Once this has all been agreed, we are also in discussion of possibly actually selling 3D printers via our website. So once that all comes into place, it'll make it easier, make it cheaper, make it more affordable to be able to use our services rather than being put off by high prices. I can be wrong, but I think we are one of the only 3D printing companies or the additive manufacturing companies offering this service at this time. So anyway, that is Dwight Mitchell from Mitchell & Son Additive Manufacturing, doing a little explanation of 3D modeling and 3D rendering, but also here to say we understand that times are tight for individuals, for homes, and for businesses at this time. And therefore we are extending an olive branch to try and make that a little bit easier for people at this time. So I thank you for listening to us. I'll say if you've got any questions, you can email us at info@mitchellson.co.uk. That's info@mitchellson, mitchellss.co.uk, and we will be glad to help you. If you need to give us a call, my mobile number, my personal mobile number is 07876 131 539. Thank you for listening and enjoy the rest of your day. Cheers. Goodbye.